Welcome back. In this lesson, we are going to implement the final step or step 1, right? Which is finding the best feature. And as you might have guessed, we are going to use steps 2 and 3 to find the best feature, okay? So the input for this function should be only x and y, right? Because we want to find the best feature, right? So this is the output of this function. So the output of this function is the best feature to split on and the best split value also, right? So we are calling step 2, and from step 2 we can get the best split value, right? So this function should return the best feature and the best split value, okay? And as we said, the objective of this function is to compute and return the optimal attribute to split on and the optimal splitting value. So here we have the same example we had before. We have x, 5 rows, 3 columns. We have y, 5 labels, the same everything as before. And the starting entropy is 0.971. We can calculate it from y, right? Now, we want to calculate the information gain at different splits. So what we are going to do is that we are going first to split based on feature 0 and find the maximum information gain we can get, right? So the maximum information gain from feature 0 is 0.32. And from feature 1 is 0.17, and from feature 2 the maximum information gain is 0.4199. So from this we can conclude that the best feature to split on is 2, right? This feature. And the best split value is 22. Now let's see how we can implement all this. So first we are going to initialize the best information gain with 0. We are going to initialize the best feature with 0. The best split value was also 0. And then we are going to loop over all the features. So if we get x3, then this is the first example, right? So this will return the first row, and the length of the first row should correspond to how many columns we have. So we have 3 columns. So if we just write range 3, then we are going to loop over 0, 1, and 2, right? So the feature index or the column index. What we want to do inside this loop is to find the best split. So how we are going to do so? We are going to call find best split using different features. So we are going to try all the features, right? Just like what we did when we found the best split value, right? So this should return the current best split value, and it should return the current best information gain, right? Because it's returning the best information gain and the best split value. After that, we are going to say if the current best information gain is better than the best information gain we got before, then the best information gain is actually the current best information gain, right? And the best feature is the current feature, and the best split value is the current split value, because the find best split will return the best split value and the best information gain. So if the best information gain of this feature is better than the best information gain of all the previous features, then this means that the current feature is the best one to split on, right? And its best split value is actually the best split value overall. So this function should return the best feature and the best split value. It's very, very simple. Given that you understand now how we can implement step 2 and implement step 3, this function should be a piece of cake. Now, in the next lesson, we will see how we can put everything together and how we can create our own decision tree from scratch. So let's go.